तू स्क्रिप्ट खोले। Yeah, good evening, Vikhyat. I'm Kapilesh. Am I audible?
Sir, you're audible.
Yeah. Okay.
Yes, sir, you're audible.
Okay, I am opening my presentation actually.
Yes, sir. So we'll let more people join and then we can continue with it.
Okay.
So,
Yeah, just a moment. Yeah. Yeah, Vikhyat. Yeah, am I audible?
Yes, sir. Yes, sir. Audible.
Okay, okay. Good.
sir, wait for only 3 minutes, then we can start.
Mhm.
Hello, sir. Sir, please share your PPT.
Kapilesh sir, can you hear us?
Yeah.
Okay, sir.
Yeah, I can hear you. Yes. So what should I do now?
Sir, you have to share your PPT.
Okay. Hmm. No, I have shared actually.
Yes, sir, it's visible.
But right side, this lot of so many people are visible, and I think it is covering my PPT also.
You have to, there will be 3 tabs. So once there will be one for single screen that you have to click.
In share. Okay,
No, no,
one
no, no.
sharing
You have
option.
to change the view.
Where is the view actually?
Anish, you are using the laptop. Please check this thing.
Yes, sir. Yes. Sir, you can pin your PPT, so it will
No, you
visible.
have to tell him how to pin it.
So just tap on the three tap of your screen of your window.
Yeah, that I am getting share, pause, layout,
Yes, sir.
uh,
So,
side control, show meeting, more. More. It has come. What should I do now? This I have clicked.
uh,
Spotlight this share.
sir, your screen is sharing in PPT mode. Just open the. You should leave your meeting mode to your screen mode. To yours screen mode, sir.
Meeting mode to screen mode. No, but how to? Okay. Now I have gone. Okay. So now it is coming.
Anish, I think so. We have around 46 member. Kapilesh sir, can we wait for another 5 minutes so that we can wait for another participants also?
No problem. I have no problem actually. I have shared my PPT. I am ready. As soon as you tell me, I will start my presentation. Okay.
Okay. Anish, so please ask in the FDP group and write a message that to the people that they join fast.
Yes, sir.
Okay.
Yes, sir.
Okay. In the meantime, I will bring water for me. Okay. Yeah.
Yeah, sure, sir. Sure, sir.
Sir, now link is shared in WhatsApp group. Can we start the program?
Yeah, Nakulji.
Yes, sir. I think so. Around 60 candidates are there. So they
Okay,
will join. They will be joining in the meantime. So I think, sir, we can start.
okay.
Yes.
So,
So I think so, sir. First, Anish will start with your introduction. Then we can start.
okay.
Anish is now it's your turn.
Okay, sir. Good evening, everyone. Namaskar, and a heartily virtual welcome back to day three, the midpoint of the AICT Atal Academic sponsored FDP on digital construction and green design pathway to net zero. We, the Innovation Cell, NICMAR Delhi-NCR, are fueled by your continued dedication to the crucial initiative. This FTP is designed to empower our faculty, scholars, and professionals with the knowledge required to drive the sustainable transformation towards net zero emissions in the built environment. Reflecting on the journey, the first 2 days have been immensely successful, laying the foundation, management, contracts and audits, material, decarbonization, and methods precast. The focus of day three is we move decisively into a highly specialized and vital aspect of sustainability, structure, longevity, and aging management. The most sustainable structure is the one that lasts the longest, minimizing the need for costly and resource intensive replacement. This commitment to durability is foundational to any genuine net zero goal. We expect today's session is to be just enlightening, insightful, and forward thinking. We kick off our technical session of for the day three with session 5 running from 6 p.m. to 7:30 p.m. The session topic is aging management of existing civil structures. This topic is paramount, especially as Indian work to ensure the safety and longevity of critical infrastructure built decades ago. Understanding how to manage the aging process is the technical, environmental, and economical necessity. It's my distinguished honor and privilege to introduce a scientist, engineer, and an academic leader, one of India's most prestigious research institution, Dr. Kapilesh Bhargava. Dr. Bhargava currently serves as the head Civil Engineering Research Section Engineering Service Group at the Bhabha Atomic Research Center, BARC, Mumbai. His career provides an unparalleled blend of foundational excellence and specialized engineering. Dr. Bhargava joined BARC in 1991 and was awarded the Homi Bhabha Prize for securing the first rank among all the engineering trainees in his batch. He later earned his doctorate of engineering in Japan after awarded the JSPF Ronpaku Fellowship. He brings an exceptional wealth of knowledge with 34 years of experience in his highly technical field. He is well known expert in structural mechanics and reliability. His pioneering research is focused on the time dependent degradation and reliability assessment of corrosion affect RC structure and probabilistic seismic margins. Assessment of age-old existing civil structure. Due to his outstanding contribution, Dr. Bhargava has been bestowed upon the title of professor in the Department of Engineering Science by the Academic Council of Homi Bhabha National Institute, Mumbai. He has also contributed to international competition exercise of IAEA. We are privileged to learn from his decades of work in ensuring the integrity and lifespan of critical national assets, a standard of durability that must guide our path to sustainable construction. After that, after this presentation, the platform will open for question. I invite Kapilesh Bhargava to share his experience, expertise. Sir, the virtual platform is all yours. You can begin now.
Yeah. So, good evening to everybody, and thank you very much, Anish, for my brief introduction. And it's my pleasure to share my experience, what we have been doing for last 34 years at this platform. And I'm thankful to particularly to Professor Rajesh Goyal as well as Professor Nakul Gupta to give me an opportunity to share what we have been doing in our organization for last 34 years. So this is the topic of my presentation, that is aging management of existing civil structures. So this will be the outline of my presentation, and here I'll be discussing mainly about the aging management program for existing civil engineers, and then it will be followed by a case study what we have carried out for residential buildings in Mumbai actually. So, first question comes to mind, that is why aging management of civil structures is needed. So the reason is that if we look around the world, we may find large number of infrastructure which has been constructed about 50 years ago or more than that, and they may have got exposed to this extreme environmental conditions, and because of that, they may have suffered some kind of degradation, some kind of deterioration, and because of this degradation and deterioration, their serviceability may get affected. And yes, we also know that if you would like to preserve this aging infrastructure, then the cost associated with with preserving the aging infrastructure would be very high. And we know that we have very limited funds for their maintenance. So if we combine both this aspect, then it poses a significant technical and financial challenge. So hence what we need a systematic approach for risk-informed condition assessment of the aging infrastructure or maybe existing buildings. So aging management of civil structure, it basically involves a proactive risk-informed strategy, and that ensures the long-term safety, functionality and sustainability of built environment. Now, there are four primary reasons. Because of that, aging management of existing civil structure is required. Number one is public safety and the mitigation of risk. Number two, the economic efficiency and cost management. Number three, operational continuity and reliability. And number four, environmental and sustainability aspects. So these four reasons I'll be discussing subsequently in my slides. Okay, now if we look at the Eurocode EN 1990, then what we have found, as per the Eurocode, the design service life of concrete structure is about 50 to 60 years. So if we have a proper aging management plan, then that plan will ensure the structural safety, functionality and sustainability even beyond the codal design service life of structure. So this is the main reason why we need an effective aging management program. Okay. Now the first reason is public safety and risk mitigation. So what happens here? We try to ensure that our structure remains safe for use under normal operating condition as well as the extreme loading conditions. So this is our main requirement, means so that we can prevent the injuries and fatalities to the general public. And if we carry out the regular assessment, that will help in identifying and addressing the various issues like material degradation and corrosion of reinforcement, particularly cracking in RCC structures. And if we identify and address those issues before before the capacity of the structure is compromised to withstand the desired load, so this is our main criteria. Now we also know that aging infrastructure is very much vulnerable to extreme weather events and natural disasters such as the occurrence of earthquake, severe wind, tornadoes, floods, and severe temperature due to solar radiation, etc. So the management program will help strengthening the structures against these extreme weather events and thereby ensuring that they can resist, absorb, and recover from such events safely. Second reason is economic efficiency and cost management. So usually proactive aging management program is less costlier than the reactive you can say reactive maintenance or reactive repair or reactive or you want to reconstruct the entire building in case of some damages. So what happens if we carry out timely maintenance and minor repairs time to time, that can prevent major expenses in the near future, because usually the cost of the major incident is very much higher than the cost of preventive management. Okay, so if we already know, if we carry out regular in-service inspection, we carry out regular maintenance, and we carry out timely minor repair, the cost can be reduced. Okay, now what happens if we carry out risk assessments? Risk assessments through structural analysis. Time to time, if we carry out, then it will help to know okay, what are the critical assets which require immediate attention. And this ensures that we can utilize the limited funds most effectively. And unexpected failures of various services like road closures, power outages, water main breaks, etc., they usually lead to significant loss of income as well as the economic disruptions. So proactive management usually ensures continuous operation of these services safely over the entire service life of the structure. Third reason is operational continuity and reliability. So basically some of the civil infrastructure systems like roads, bridges, water systems, energy grids, they are basically critical for societal stability and economic growth. And aging management ensures that these systems continue to provide the required level of services safely. So for which what we do, we carry out regular in-service inspections, and this in-service inspection ensures that the infrastructure can withstand the current demands in terms of current loadings, and this current loading may be much more higher than the original design basis loading which has gone into the original design of the structure. And this management practice that also will ensure that the original reliability margins and performance levels can be ensured throughout the service life of the structure. And last major reason is environmental and sustainability aspect. So usually if we rehabilitate and retrofit the existing structure, it is basically a more sustainable option rather than going for the demolition of the structure and constructing a new structure in case of damages, because it will also minimize the waste generation. Now, if we utilize some of the innovative materials like green concrete, recycled materials, energy efficient system, etc., during the maintenance, then it also aligns with the global sustainability initiatives. And this further helps in addressing the climate change impacts. Now, what happens due to the aging of structures? So, because of aging of structures, there will be gradual change of structural characteristic with function, with time, or with use. Now, I try to analog that structural aging with human aging. Like birth of a human can be related to initial design and construction of the structure. That stress on human being can be related to operational and environmental exposure to the existing structures, and preventive care on human being can be related to regular inspection and maintenance of the structure. So now we have come to know that aging of structures, it may cause basically reduction in design margins, and safety functions can be impaired, and there could be collapse or non-functionality during the design basis accidents, what we have envisaged during the design stage of the structure. So all these factors basically call for effective aging management program of the structures. Now, what would be the aging management program for existing civil structures? So since I come from Department of Atomic Energy, so for our kind of structures, I have listed some of the IAEA, AERB, ACI guides which we normally adopt for our kind of structures. IAEA means International Atomic Energy Agency. AERB is Atomic Energy Regulatory Board of India. ACI is American Concrete Institute. So I have listed some of the guides over here, okay, which are used for aging management program of nuclear safety related structure or industrial structures, both. And our BARC, in our BARC, there is one BRC Safety Council. They have also come up with a safety manual entitled Aging Management and Structural Assessment of Existing Concrete Structures. So all these guides and codes what I have listed, they can be utilized for the aging management of existing structures. Now, what would be the approach for aging management program, effective aging management program? So there are basically 5 steps in the effective aging management program. First step would be the health assessment. So basically health assessment of structure starts with visual inspection and then it is followed by the non-destructive testing as well as partially destructive testing on the structure. So this non-destructive testing and partially destructive testing, what they give us, they provide the quality of in situ concrete in the structure, they provide the compressive strength of the in situ concrete, they can provide information related to some chemicals in the concrete, presence of chemicals like chloride, chlorides, sulfates, and pH of the pore water solution, and they can also provide the information pertaining to the probability of reinforcement corrosion. Okay. Now, second step would be in the effective aging management program would be the structural assessment. So here what we do, we carry out the structural analysis. Okay. So here I have listed the seismic reassessment exercise because what happens day by day, seismic hazard is increasing. So many of the facilities which have been constructed, say maybe 50, 60 years ago, using the seismic criteria available at that time may not satisfy the current seismic criteria. Okay, so here we can carry out this seismic reassessment exercise to find out where we have got the deficiency as far as the structure is concerned. And if this may, another thing may also happen, like use of the structure has been changed or functions of the structure has been changed. So that may result in the increased loading. So that also could be analyzed for deficiency present in the structure. So third step would be the mitigation of degradation. So once we have carried out the structural analysis, we can very well identify the critical locations. And these critical locations we can identify for what? Possible repair and retrofitting. Okay. The fourth step would be the monitoring of degradation. So structural monitoring can then be carried out by installing and fixing some sensors and or strain gauges in the structure. And last step in the effective aging management program would be the maintenance strategy. So this will basically involve the in-service inspection and preventive and remedial maintenance time to time. Okay. Now, for our kind of structure in our department, there are some regulatory requirements. Like if my facility or structure is in normal operation, normal operation, then we have to carry out that detailed periodic safety review once in 10 years. And if for safety related structures or water retaining structures or stack, the in-service inspection has to be carried out once in 4 years, and for other buildings it is once in 8 years. So safety related structure means nuclear safety related structure where radiological hazard is involved. Okay, and if we want to consider the structure for the possible life extension, then life extension review should be carried out at least 5 years before the end of the design life, which I have shown in the previous slide. So as per some Eurocode, it is about 50 to 60 years if we follow all the codal guidelines and design the structure. And also we have to carry out in-depth review of the aging management program as per the AERB guidelines. Now I will discuss about the this aging management program in slightly detail. Okay. So here the first step would be the health assessment of structure, which starts with the visual inspection. Okay. So this is in visual inspection what we try to do. In visual inspection, as a first step, we try to collect the general information pertaining to the building. Now, what are these general information? We try to collect the as-built construction drawings. We try to collect the original design basis report. We try to collect the original structural analysis report, seismic analysis report, and design reports. Okay. Then after we try to collect even geotechnical parameters, what has gone into the original design of the structure. So all this data we try to collect during first step. Okay. Then after collecting this data, we go for the inspection of the structural system of the buildings. We try to match the structural system with the as-built construction drawings. And we try to find out whether any addition or alterations in the buildings have been carried out or not. Because sometimes this addition and alteration may result increased loading in the buildings. Okay, so that we have to find out very carefully. And during visual inspection, we also try to find out is there any dampness or leakage present in the building. Then yes, so in existing in civil structures, the degradation in structure can be due to three factors. It could be physical, it could be chemical, and it could be biological. Okay, so this slide particularly shows the physical damages in the structures, and this may be due to plastic shrinkage, this may be due to drying shrinkage, this may be due to thermal stresses developed due to high temperatures, and damage may occur due to some overloading, damage may occur due to vibrations of any machinery or equipment, and damage may occur due to some fire. Chemical damages in structures basically occur due to two factors. One is chloride attack, another one is carbonation. Okay. This slide basically shows the corrosion damage to the structure. So basically what happens when reinforcing steel corrodes, then corrosion products are formed. So usually the volume of these corrosion products is 1.6 times to 6.2 times of the volume of steel which has undergone the corrosion process. So what happens? This increased volume, it applies radial outward pressure on the surrounding concrete. Okay, so concrete which surrounds the reinforcing bar. And because of this radial pressure, what happens? Hoop tensile stresses are developed in the surrounding concrete. And once this hoop tensile stresses exceeds the tensile strength of the concrete, then cracking occurs. So this cracking initially occurs at the rebar concrete interface, and continued corrosion products process will result the propagation of this cracking from the rebar concrete interface to the outward direction till the cover is fully cracked. So because of this corrosion, we can see corrosion cracks have appeared at the surface, and reinforcement has got exposed, and basically corrosion damage results in three types of damages. Number one is reduction in cross-sectional area of the steel. Number two is reduction in cross-sectional area of concrete. And number 3 is reduction of bond between the concrete and steel. Okay. So if my structure is exposed to microorganisms, presence in algae or sewage, etc., such kind of damage occur, which are shown in the slide. Okay. Now, after going for visual inspection, we carry out the NDT and PDT on the civil structure. NDT means non-destructive testing, PDT means partially destructive testing to find out the condition of concrete in the existing structure. So these are the usual tests like rebound hammer test, ultrasonic pulse velocity test. So these two tests basically provide the quality of concrete in the existing structure. Okay, then concrete core test and half shell potential test. These are basically partially destructive tests, and concrete core test will give you the idea about the compressive strength of the in situ concrete. Half shell potentiometer test will give the probability of reinforcement corrosion, whether reinforcement corrosion has started or it is yet to start. Okay, then another test we do is carbonation test, whether carbonation has started or not, and this is usually carried out on the extracted core. And then chemical test is also carried out to find out the chloride content, surface content, and pH of the pore water solution inside the concrete. Profometer scan will reveal the location of reinforcing bars in the existing structure. So these are the various tests we carry out on the existing structures. And here I have defined this flow chart. Means health assessment basically starts with visual inspection. Then we carry out non-destructive test and partially destructive test. So non-destructive test means rebound hammer test and ultrasonic pulse velocity test, as well as profometer scan. And partially destructive tests are extraction of pores and half shell potential test. And once we extract the core, we carry out the carbonation depth test on the extracted core. And then these cores are tested to find out the compressive strength of the in situ concrete. And then we carry out the chemical analysis of chemical analysis of the concrete, which we obtain from the broken cores to find out the chloride content, sulfate content, and pH of the this pore solution. So this chemical analysis is carried out in laboratory. Now, second step in effective aging management program would be the structural assessment of civil structures. So basically, we carry out seismic reassessment exercise. So yes, this is the most challenging stage in the aging management program. So here we try to create finite element model of the structure, and a typical model is shown in the slide. And we go for static analysis, we go for seismic analysis, and this is basically a iterative process. Okay, and these are the reference codes to carry out the structural assessment part. And for nuclear safety related structure, we usually use ARB guides and IAEA guides. And for industrial structures, we use BIS 1893 and 456 codes. Okay. So here for structural assessment, the 3D finite element model is generated by using the actual material properties. Here, what does it mean by actual material properties? Actually, if you look at the as-built drawing, some grade of concrete is mentioned. Design basis report, some grade of concrete is mentioned. Here, actual material property means we are carrying out the partially destructive test to find out what is the compressive strength of the concrete in the in situ concrete. Okay. Then actual or proposed loading conditions and load path. What is actual load path? If you look at the original design basis report, they have mentioned this floor is designed for 300 kg per meter square, or this floor is designed for 500 kg per meter square, like that. But what happens once the facility is commissioned, we actually calculate the load due to the installations. And if we actually calculate the load due to various installations, they may come out to be lesser than what we have envisaged in the design basis report at the time of original design of the structure. And yes, here the actual member sizes and boundary condition is as built drawing we already have. From there we can take, and actual geotechnical or soil parameters. So this why I am telling actual geotechnical, because if you consider the older buildings, 50 years or 60 years old buildings, at that time this geotechnical investigation etc. were not that strong as we are having today, all the facilities. So we can carry out the geotechnical investigations at the site, find out the current geotechnical parameters like safe bearing capacity, shear wave velocity, mass density, and other soil parameters. And yes, in the analysis, we also account for the soil structure interaction effects. And here we carry out the range analysis. What does it mean by range analysis? So in soil structure interaction, we usually go for the modeling of soil media by frequency independent soil springs. So when we calculate the stiffness of frequency independent soil springs, then one parameter is required, that is shear wave velocity. And using the shear wave velocity and mass density, we can calculate the shear modulus, that is G. Okay, so range analysis to account for the uncertainty in the soil, what we do, we carry out the analysis using G by 2, G and 2G. Okay, so this is the meaning of range analysis. And of course, this entire exercise we carry out for the review basis ground motion. Means review level earthquake. Review basis ground motion is usually higher than the ground motion which has gone into the original design of the structure. And this may be due to the change of zoning due to the higher seismic hazard as per BIS 1893. And this is the flow chart I have given for the seismic reassessment exercise. So what we do, we model the structure. As a first step, we generate the finite element model using the actual strength of the concrete, actual loading of the structure, plus review basis ground motion. So we analyze and calculate the total demand in all the structural elements, and then we compare with the total capacity of the structural elements. So if the demand is less than the capacity, then there is no problem. I can say my structure is qualified. But if my demand for some of the members, if my demand is more than the capacity, then what we have to do? We have to go for retrofitting option as a second step. So we design the retrofitting scheme for such elements. And after designing this retrofitting scheme, we again analyze the structure with actual loading, actual strength, and review basis ground motion. Why we are analyzing second time? Because of the retrofitting scheme, the strength and stiffness characteristic of the original structure has got changed. So we go for the second analysis. And here, if total demand for all the structural elements is less than the capacity, then fine, my structure is qualified. Otherwise, I may have to find out the other location where the structural members may require the retrofitting. Okay, so this is why I have told this is an iterative procedure, and this procedure we carry out till for all the structural elements demand is less than the capacity. Okay, so now, after retrofitting, after designing the retrofitting scheme, we can even go for how much seismic margins we are margin is available with respect to the seismic demand. So for this, we usually carry out the nonlinear static pushover analysis. So this is the entire flow chart for carrying out the structural assessment, that is seismic reassessment exercise. Now, third step in the effective aging management program would be the mitigation of degradation. That means repair and retrofitting of the civil structures. So yes, now there is a very slight difference between repair of structures and retrofitting of structures. So repair means we are trying to restore the original sizes, original cross sections of the structural members. And by retrofitting means we are trying to restore the original capacity of the member, or we are trying to increase the capacity of the member. So this is the slight difference between the repair and retrofitting of structures. Now, uh, uh, this repair and retrofitting requirements can be evaluated, as I told, based on the distress assessment. And for finding out the location of distress, we have to carry out the structural analysis. This can also be assessed based on the functional or performance objective. Means what is going to be the function of the structure, what kind of performance you are looking forward to. So this also plays a major role in evaluating the repair and retrofitting requirements. And it can also be based on the residual life, means how much life the structure is having and what are the safety requirements. So these three parameters decide the evaluation of repair and retrofitting requirements. Now, if, repair and retrofitting schemes can be evaluated based on the structural assessment. And structural assessment is an iterative process that I have explained in the previous slides. And this also depends on the type of material or type of alternatives. You know? So what are the different kind of, if I say retrofitting, if I speak about the retrofitting scheme, it could be global retrofitting or local retrofitting. So what kind of alternative you are choosing, that depends. Then accessibility or constraint, whether we have proper access to carry out repair or we have proper access to carry out retrofitting, that also plays an important role. And yes, whether I can carry out repair or retrofitting, uh, even if my plant is running, even if my facility is under normal operation, or we have to shut down the plant or we have to shut down the facility to carry out the repair or retrofitting, it also plays an important role. Okay. Now cost. Cost is a very important factor, and that can be assessed based on techno-economical solution. So here I have put as a thumb rule, if the cost of retrofitting is less than 50% of the cost of reconstruction, then I should go for retrofitting. And if the cost of retrofitting is greater than 70% of the cost of reconstruction, then I should go for reconstruction. This is a normal thumb rule which is adopted uh, as far as this repair and retrofitting schemes are concerned. Now, there are various methods of repairs. This slide shows coatings. Coatings as the method of repair on the entire floor for a particular floor. And here we can use protective seal coat on the entire surface. We can also use anti-carbonation coating. We can also use corrosion inhibitor coating. We can also use low viscosity epoxy coatings, acrylic emulsions, asphalt coating, fire resistant coatings. Depending on the requirement, these are the various kinds of coating which we can apply on the entire surface and repair it. Now, cracks can be repaired using epoxy grouting. They can also be repaired using polymer modified cement slurry injections. Okay, and thin repairs can be carried out using the polymer modified cement mortars, and it can also be carried out by epoxy mortars, thin polymer epoxy overlays. So these are thin repairs means there are very small cracks at lower, very less locations. And thick repairs, that basically involves the replacement of the entire concrete. Okay, so this can be carried out by using polymer concrete or epoxy bonded concrete or superfluid micro concrete, silica fume concrete, like that. And leakages can be repaired using silan and siloxane sealing compounds, epoxy coating, epoxy grouting. So these are various methods of repair which I have listed here. Now, next step comes to the methods of retrofitting. Retrofitting means strengthening. I am trying to restore the original capacity, or I am trying to enhance the original capacity. So there are two kinds of retrofit. One is global retrofit. So in global retro, and another one is local retrofit. So in global retrofit, we add new structural elements, and these new structural elements, it could either be RCC wall. It could either be steel bracing or tensile bracing, concrete or steel buttresses, energy dissipation, dampers. So, by using this additional structural elements, what happens? The result will be the enhanced lateral load carrying capacity, enhanced seismic margin. Okay. So this slide particularly shows the example of addition of RCC shear wall as a global retrofit. This slide basically shows an example of steel bracing or tensile bracing as a retrofit option. This slide basically shows concrete and steel buttresses as a as an example of global retrofit to the existing structure. This slide shows addition of viscous dampers to the existing structure as an option of global retrofit. Now, another method is local retrofit. So here in global retrofit, we add new structural elements. In local retrofit, we strengthen the original member itself. The strengthening can be carried out either by reinforced concrete jacketing or steel jacketing or FRP wrapping. Okay. So this slide shows the concrete jacketing of column, beam column junction and beams as an example of local retrofit. This slide shows the steel jacketing of column, beam column junction and beam as an example of local retrofit. This slide shows the FRP wrapping of beams, beam column junction, and columns as an example of local retrofit. Now, another example I have shown for local retrofit is shotcrete. So basically what happens, there is one RCC shear wall, and if I want to increase the thickness of that RCC shear wall, existing wall, then how can I do? I can put another layers of reinforcement over it, properly embedded with the existing one, and then I can go for shotcreting to increase the thickness of the existing shear walls. And right side figures, I have shown this local retrofitting of footings, where the cross-sectional dimensions, planned dimensions and thickness have been increased, and additional reinforcement has also been provided to improve the strength of the footing as an option of local retrofit. Now, fourth step in the effective aging management program would be the monitoring of degradation in structures. So structural monitoring can be carried out by using sensors or maybe strain gauges. Like embeddable corrosion monitoring sensors can be used assessing repair effectiveness. Vibrating wire strain gauges can be used for measurement of strains. Hanging pendulums can be used for measurement of horizontal movements. Extensometers can be used for measurement of deformations. And dynamometers, load cells, they can be used for measurement of load transfer within the structure. Fiber optic sensors can be used for structural strain, cracking, or temperature monitoring. And acoustic emission monitoring can be used for sudden redistribution of stresses. And some figures I have introduced for corrosion monitoring sensors, vibrating wire strain gauges, fiber optic sensors. These representative figures I have put up. So by providing these sensors or strain gauges, we can monitor the structure at regular intervals or time to time. Last step in the effective aging management program would be the maintenance and in-service inspection, maintenance strategy. which will involve the in-service inspection and the preventive and remedial maintenance. Okay, so basically we carry out based on the structural assessment, we can carry out the preventive maintenance. We can increase the capacity of the structural members. Okay, and we can carry out the remedial maintenance based on the structural analysis, and we can carry out in-service inspection of the critical components, and based on the instrumentation and periodic data monitoring, we can get a lot of information about the existing structures. And now the basic question comes is frequency. What would be the frequency of inspection and maintenance? Okay, so I have put this particular slide actually. So here the frequencies of entities have been mentioned based on our BSc safety manual. So here first data should be collected before the commencement of the operation, and this data will be known as the baseline data. Second data should be collected after 30 years after the commencement of operation or functioning of the structure, and this basically will be required to assess the health of the structure by comparing with the baseline data. Okay, successive data should be collected every 10 years after 30 years after commencement of operation or functioning, and this will be useful in assessing health of the structures by comparing the data collected at different intervals. Okay, so this is all about the effective aging management program of the existing civil structures. Okay, now I will move to a case study of the existing residential buildings in Mumbai. So this exercise we have carried out. This exercise basically has been carried out by one of my MTech student who has completed his MTech from Bhabha National Institute. Okay, so this reasons, remedy, and aim of the aging management program or condition assessment of existing buildings have been explained in the previous slides. And here, one thing I would like to mention, that is Section 353B of the Mumbai Municipal Corporation Act 1888. So, what does this act says? This act says that every owner of a building shall carry out structural audit within 1 year from the expiry of 30 years, from the expiry of period of 30 years and 10 years thereafter. So in the previous slide, I have shown the frequency of carrying out NDTs and PDTs on the existing structure based on BSc safety manual. So both align well. Okay. Now, for this carrying out this case study, we have considered the area of Anushakti Nagar. Basically, Anushakti Nagar is the residential colony of Department of Atomic Energy, which is spread over about 945 acres. And here, the residential structures have been constructed between 1969 to 2006. And for the present study, we have considered 79 structures. Now, depending on the age of the structures, we have divided these 79 structures into three categories. That category A is having 29 structures, and for which the age of the structures are above 50 years, and grade of the concrete, which was originally used, is M15, and height of those structures vary between 10.5 meters to 16.5 meter above ground. Category B structures, the age is between 20 to 50 years, and concrete grade involved are M15, M20, and M30, and height varies from 6.5 meter to 62 meters. And there are 39 structures which fall under category B. And category C, for which the age of the structure is less than 20 years, and there are total 11 structures. and grade of the concrete used is M15 and M30 in the original design, and height varies from 11.5 to 13 meters. Okay, the plant dimensions of all these structures vary from 15.6 meter by 14.3 meter to 151 meter by 7.5 meter, like that. And mostly all these buildings are RCC framed structures, and wherever required, shear walls are also provided. Now, as a first step, we have carried out the visual inspection of all these 79 structures. So what we have found? We found that the building dimensions and number of floors, they are verified with respect to the original wood for construction drawings. Means whatever was mentioned in the drawings, it matches with the original structure, and there was no major alterations in the buildings. Okay, that means the function and use of the building remains the same. Okay, there were some localized surface cracks and spalling of concrete at some locations in the external beams, columns, and chhajjas, and this could be attributed due to the exposure to the severe environmental condition, that is marine environment, because Bombay is nearer to sea coast. Okay. Then some localized cracks in the masonry walls at some locations were also observed. Dampness at some locations in the masonry wall also observed, and there was no potential non-structural falling hazard in the buildings, and there was no distress or structural damage in the buildings. Okay, so these localized surface cracks and spalling of concrete, localized cracks in the masonry walls, dampness, they were immediately repaired to the original condition, suitably repaired to the original condition. Okay. Then we have carried out non-destructive and partially destructive tests on all these structures, and we have carried out this rebound hammer test, ultrasonic pulse velocity test, core extraction, then carbonation depth, half cell potential meter, and then we also carry out this chemical analysis to find out the chloride content, sulfate content, and pH of the pore solution. Okay. Now I will present qualitative analysis of the various non-destructive tests and the partially destructive test. So this slide shows the qualitative analysis of the rebound hammer test. So for category A building, means there were 29 buildings. The sample size was 1130. Means 1130 locations we have carried out this rebound hammer test. And for category B, the sample size was 1354. And for category C, the sample size was 219. Category B is having 39 buildings, category C is having 11 buildings. And what we have found? So we have found the mean value of rebound number is around 30 for all the category A, B, and C. And if you look at the right side figure, that is histogram, then we find that more than 90%, more than 97% locations have revealed fair to good to very good hard layer of concrete based on this rebound hammer test. Okay. Then second test was ultrasonic pulse velocity test. Okay. So yes, depending upon the situation, direct test, semi-direct test, indirect test, these three tests have been carried out, and suitable correction factors have been applied using the BIS 516 Part 5 Section 1 2018 latest code. Okay. For category A building, sample size was 1144. For category B, the sample size was 1382, and for category C, the sample size was 256. Okay, so mean value was found to be around 3 kilometers per second for all the category A, B, and C building. Now let us see the pulse velocity results in the histogram form. So yes, we find that about 85% of the samples are showing uh, either doubtful concrete or poor concrete. This is based on the latest code. And if I say if I consider the earlier code 13311, then what happens? Majority of the concrete will be on the other side, means medium, good, and excellent grade. Okay, so this is the difference because of the new code I have observed. Now, third test was this core strength test. Okay, that is, we have extracted the cores, and for category A buildings, number of samples were 54, and for category B, number of samples were 66, and for category C, number of samples were 13. Okay, and we have presented results in the form of a non-dimensionalized number, that is RFC, and RFC is nothing but the ratio of in situ strength of concrete divided by the design strength of concrete. Say my grade of concrete is 15, then my design strength is 15, I have considered like that. And in situ strength means I have taken out the core, cylindrical core, I have found out the cylindrical strength, I have corrected it based on the length to diameter ratio, and then I have converted it to the equivalent cube strength. Okay, so what I have found out? I have found out that mean ratio, that is RFC, is 1, nearly 1 for all the categories of buildings. That means uh, uh, degradation in the strength is barely minimum. Okay. And if you here, if you look at the histogram, then you can find out that more than 95% of the samples, they reveal that the RFC is either 0.75 or more than that actually. So if I am getting the RFC as 0.75, that is a very good, because when we design a RCC section, then what happens at the extreme value compressive strength, we consider about 45% of the characteristic strength. Here if I am getting 85% or 75%, that is good, because this is the actual strength. Okay, then another test was half cell potential test that we have carried out, and sample sizes were 351, 384, and 102 for category A, B, C respectively, and mean value is observed to be about minus 250 millivolts for all the category A, B, and C buildings. And if I look at the histogram, then what I have found? I have found out that 90%, more than 92% locations have revealed that there is a very less chance of corrosion, or corrosion chance is uncertain. Okay, so this is what I have observed from the half cell potential test. Another test is carbonation depth test. Okay, so on the extracted cores, we have carried out this carbonation depth test. Here also we have presented results in the form of non-dimensionalized number, that is RDC, which is RDC is nothing but the depth of carbonation divided by the clear cover to the reinforcement. Because we have carried out this test for beam, column, and slabs also. And if you look at the BIS 456, the clear cover to the reinforcement to different structural members will be different. So that is why we have presented results in the form of non-dimensionalized number. Okay. If you look at this histogram, then what we found? We found out that about 80% of the locations where the carbonation depth has yet to penetrate the reinforcement, where this RDC is found to be less than 1, means that carbonation front has not penetrated the reinforcement. So carbonation induced corrosion chances are almost negligible. Okay. Then we carried out this qualitative analysis for chemical analysis, that is chloride content in the concrete, in situ concrete. Okay, so chloride is expressed as kg per meter cubed of the concrete. So for category A, B, C, all these buildings, the sample sizes were 30, 41, and 9, and mean value is 1.31 kg per meter cube, means about 1.4 kg per meter cube we have got. And if you look at that, more than 50 to 60% of the location have revealed that chloride content has exceeded the permissible value of 0.6 kg per meter cubed of concrete as per IS 456. And this could possibly the reason that some localized cracking, localized falling of cover concrete, which was observed in the external members. This could possibly be the reason. Then another thing was sulfate content present in the in situ concrete. So sulfate is expressed as percentage mass of cement. Okay. So for category A, B, C, 30, 41, and 09 samples were there, and mean value is found to be about 0.62, 0.66, and 0.63 for different categories. And if you look at that, 100% of the samples, they reveal that the sulfate content is less than the permissible value which has been provided in EIS 456. That is 4% mass of cement. It is less than that. Okay. Then other test was pH value of the pore solution. 30, 41, and 9 samples were considered for category A, B, C buildings. And what we have found out, now there is one paper by Kakade et al. 2014 which says that for the existing, and another paper by Ambrosiak et al. 2019 and 2021. So these references say for existing building, if the pH of pore solution is greater than 9.5, then it is then a very good alkaline environment is maintained inside the concrete. So what we have found out, based on this reference, we have found out that 100% of the locations have revealed that pH value is much more than 9.5. So good alkaline environment is maintained inside the concrete. Now, after carrying out this qualitative analysis of NDT and PDT, next step was to carry out statistical and probabilistic analysis of NDT and PDT results. Okay, so for rebound hammer, है ना? So for rebound hammer, we have got here I am presenting the result for category A buildings. Okay, so for rebound hammer, I have found out that mean value is about 30, coefficient of variation is about 17%, and coefficient of skewness is 0.2. That means my distribution is positively skewed, and the coefficient of kurtosis is 2.92. That means more or less the distribution is similar to the normal distribution. So we have applied both chi-square test as well as the case test. And based on this test, what we have found out that individual buildings, they follow both normal and log normal probability distribution, and combination of buildings, it also follows both normal and log normal distribution, probability distribution. Then similar exercise was carried out for ultrasonic pulse velocity. So here my mean value is about 2.83 kilometers per second. Coefficient of variation is 23.8%, and coefficient of skewness is 0.856. Kurtosis is 4.34. That means my probability distribution is much more peaker than the normal distribution. And both case test and chi-square test have revealed that for individual buildings, this USPV follows both normal and log normal probability distribution, and for combination of buildings, it follows log normal distribution. Okay. Similar exercise was carried out for core compressive strength. So uh, here we have found out the mean value is about 0.99, nearly 1, and coefficient of variation is 17%. Coefficient of skewness and kurtosis are 0.81 and 3.31. Okay, and here that both chi-square test and case test have revealed that this core uh, core uh, core compressive strength, it follows both normal as well as log normal distribution. For this slide shows the statistical and probabilistic analysis of the half cell potential test. So here mean value is about 247 millivolt. Coefficient of variation is 23%. And yes, here the coefficient of skewness is 0.264 with negative sign. That means the distribution is negatively skewed. That means it will have long lower tail compared to the upper tail. Okay. Hello. Huh? Please.
Anish, please mute this
Okay.
participant.
Okay. Now, shall I continue?
Yes, sir. Yes, sir.
Yeah, I'll take another 15 minutes. I'll close down by 7:30. Okay.
Okay, sir.
Yeah. So here, this probability distribution for half cell potential test is negatively skewed. Okay, and all other tests we have found positively skewed. Okay, so here both again chi-square test as well as case test have been carried out, and what we found that for individual buildings that half cell potential test follows both normal and log normal probability distribution, and for combination of buildings it follows normal distribution. Okay. For carbonation depth test, we have found out the mean value. RDC means the depth of carbonation divided by clear cover to the reinforcement. Okay. So mean value was 0.86. Coefficient of variation, you see 56%, and this coefficient of skewness is 42.42, and coefficient of kurtosis is 2.82. Okay, so this chi-square test and case test have been applied, and we found that individual buildings can follow both normal and log normal distribution, and combination of buildings can follow normal distribution. Okay. Chloride content test. So you can see this chloride content test, it follows the log normal test, log normal probability distribution based on the chi-square test and case test. Okay. Sulfate content, it follows both normal and log normal distribution based on the chi-square test and case test. The pH value of this pore water solution, it follows both normal as well as log normal probability distribution based on both chi-square test as well as case test. Okay. Now, after first, what we have done, we have carried out qualitative analysis. Second step, we have carried out statistical and probabilistic analysis. And as a second step, we have identified which test is following which distribution. Now, after establishing the probability distribution for different tests, we have made the prediction of results. Okay. And this slide shows the estimation of median value and 95% confidence value for rebound hammer test for all the three category A, B, and C. Okay, so here you can see using both, because this rebound hammer test, it follows both normal as well as log normal distribution. So you can see as an example that actual data says that the this mean value is 30, and based on the prediction, sorry, median value is 30, and based on the prediction, we have found out 29.96 and 29.5. Okay. Actual data shows that 95% confidence value is 27. We have found out 21.42 and 22.06. So likewise, we have made predictions for this category B as well as category C. So you can see that excellent matching between the actual experimentally observed value and predicted values of rebound occurred. Similar predictions have been carried out for ultrasonic pulse velocity test. And yes, here we have used only log normal distribution, because this ultrasonic pulse velocity, it follows only log normal distribution. So for all category A, B and C, that excellent agreement has been observed between the actual values as well as the predicted values. Now, the same predictions have been carried out for core compressive strength test also for all category A, B, and C. And you can see that excellent matching has been obtained here. Okay. This slide shows the prediction for half cell potential test. So here for all the three A, B, and C, and here we have used only normal distribution, because this half cell potential test follows normal distribution. Okay. So you can see these values are matching excellently. These predicted values and actual values are matching excellently. Same thing has been observed for carbonation depth test, and here we have used only normal distribution because it follows normal distribution, and excellent matching has been observed. And this slide shows the results for chemical analysis, that is chloride content, sulfate content, and this pH content of the pore solution. And you can see this chloride content has been evaluated using this normal distribution, and this sulfate content and pH has been evaluated using both normal and log normal probability distribution. And excellent matching has been observed between the experimentally observed value as well as predicted value. So this is what I have presented for this what exercise we have done for existing residential buildings for health assessment. That was the first step, and second step would be the structural assessment. That means seismic margin estimation of the margin estimation of one existing residential building. Okay, now this slide basically show what are the reasons why we carry out seismic reassessment exercise for the existing structures. So basically what happens, uh, most of the, as I have already told, that most of the buildings have been constructed maybe 50 or 60 years before, by using the codes and the standards available at the time of their construction. Okay, now seismic hazard is increasing day by day. So this may happen that the current seismic demand is much more than the seismic demand which we have considered in the original design of structure some 50 to 60 years ago. And yes, today we have very good, proper, and with clarity, seismic design guidelines are available. But at the time of construction, 50 or 60 years ago, uh, there were not much seismic design guidelines were available. Now, there could be some change in functional requirement, and this may result in the increase in loading due to revised functionality, and this increase in loading was not considered at the time of design and construction. This could be another reason. And then consideration of the changes in its actual strength of in situ concrete. So say for 50, 60 years ago, we may have considered the grade of concrete as say M15 or M20 or M30, but there may be some degradation due to aging of the structure. There may be some deterioration of the material strength of the in situ concrete. So that also is one of the parameters why we should carry out this seismic reassessment exercise. And yes, these codes and standards are getting revised and upgraded based on the latest result. This is also one of the reason. And for us, regulatory requirement is as a part of periodic safety reviews. So because of all these reasons, the safety seismic reassessment of existing structures is needed. So for case study, we have considered one ground plus 3-storied RCC framed structure, and for which the year of construction was 2006. Design characteristic strength was M30, and height above the foundation level is 13 meters, and plant dimension was about 18 meters by 7.5 meters. So yes, USPV at 30 locations have been observed, and the 95% confidence value is about 2.1 kilometer per second, and in situ strength of the concrete is about 28.08 megapascal. And this strength has been obtained by carrying out the core test. Now, this slide basically shows the methodology for carrying out non-linear seismic pushover analysis. So I'll not go into detail of this particular slide. I'll skip it. And this was the plan of the structure, and this was the plan and elevation. Right side figure is the elevation of the structure. And these are the various loads we have considered. Vertical loads, self-weight, and by defining the density, SEP 2000 software we have used, it can calculate the self-weight, and floor finish loads have been prescribed, brickwork also has been prescribed, and live load has also been considered. And the building is located in zone 3. So zone factor is 0.16, and damping for RCC buildings is considered as 5%, and this imposed load, live load, is considered as 25% for seismic consideration. Importance factor is 1, and response reduction factor, since it is special moment resisting frame, so we have considered 5. Okay, so this is the approach for modeling of structure and analysis. We model the geometry, we define the material properties, we define the boundary conditions, and we define various loads, and then we assign the hinge properties, which is an input parameter to the nonlinear seismic pushover analysis, hinge properties to both beams and columns, and then we run it to calculate the seismic margin of the building. Okay, so this is a typical cross section of a beam, and this M5 curve under sagging condition and M5 curve under hogging condition is shown in these two figures. Okay, and this is basically an input to the SEP 2000 for carrying out nonlinear seismic pushover analysis. Okay. And yes, this slide shows the M5 curve for column members at foundation levels and at other level, that is other story level 1, 2, 3, 4. Okay. And this is another cross section of the column, that is 230 by 500. So M5 curves have been developed for this column too at foundation level as well as other story level. And this is the finite element model of the structure. Node 114 has been considered for the global X direction, and node 111 has been considered for the global Y direction. And these are the pushover curves in global X direction and global Y direction. That means base shear as a function of displacement. Then we have adopted ASC 2005, so where different performance limit states are defined, A, B, C, D. So for A, that means there will be significant damage can occur, large permanent distortions, and it will be just short of the collapse. So allowable drift limit is defined as 0.025, but B is generally repairable damage, that is moderate permanent distortion, for which the allowable drift limit is 0.015, and C is the minimal damage, limited permanent distortions, and drift is 0.01, and D is no damage, essentially elastic behavior, and the drift limit is 0.005. So these are the seismic margins at different performance limits have been observed. For LSA, that is A, the factor for seismic margin in X direction is 3 and Y direction is 2.4. For performance limit B, the factor for seismic margin in X direction is 2 and Y direction is 1.75. And for C, they are 1.5 and 1.4 in X direction and Y direction. So this has been observed in figure shows the seismic margin assessment in both global X and global Y direction, where this means capacity spectrum has been plotted with gray line, and demand spectrum for different performance levels A, B, C have been plotted. Okay, and that intersection point will give you the performance point. Okay, these are the intersection points. Now I will conclude. I will summarize and conclude my presentation. So summary of aging management program, I can say that comprehensive aging management program for existing civil structures is presented here. Different types of age-related degradations that could occur in civil structures are explained. Approach for health assessment of civil structures is presented. Seismic reassessment approach is presented. Different repair and retrofitting strategies are presented, and structural monitoring and maintenance strategies are explained. And concluding remarks on condition assessment of residential buildings, a case study. So we have found out based on rebound hammer test, it follows both log normal and normal distribution, and fair to good concrete layer is observed at 90% of the locations, and USPB is a point of concern. But what we have done, we have carried out rebound hammer test, USPV test, and core extraction at the same point. So the core extraction results are very encouraging, that more than 85% of the locations that we have got, that design strength is more than uh, 0.8, means that ratio is more than 0.8. So this is very encouraging phenomena. And USPV is fair to doubtful at about 80 to 90%, and this could be due to the presence of micro cracks, internal flaws, maybe honeycombing, etc. There are many reasons. And half cell potential test indicate that there is less to uncertain probability of corrosion in reinforcement. None of the location revealed serious corrosion situation. Okay, carbonation test. Carbonation depth is in close vicinity according to the average ratio, but this is again uncertain corrosion condition, because about 85% of the location, that carbonation front is yet to penetrate the reinforcement. Okay, chemical analysis says that chloride attack is at more than 75% location of the sample, what samples we have collected. And mostly all these samples, maybe 30, 40 samples, they may have collected from the external members only, and majorly from external, and very few samples from the internal. So because external members, we have seen some localized corrosion, cracking, localized spalling have been observed. Okay, so this may be due to the chloride attack, and sulfate content and pH values are well within the limits at all the 100% locations. And seismic margin assessment. So yes, based on this, we can identify the critical locations which require repair or retrofitting. And however, the global margin is 3 and 2.4 in global X and Y directions for limit state A, 2 and 1.75 in limit state B, and 1.5 and 1.4 for limit state C. So we can conclude that structure has sufficient seismic margin in both global X and Y direction for the different performance limits. So at last, I would like to thank all of you for listening to me with incredible patience. Thank you very much. Thank you.
Thank you so much, sir. There are a few questions from our participant side. So,
Yeah, just a
one is
moment.
from Dr. Dada Patil. That is, recently buildings in NCR got severe damages due to mixing and curing water quality, and buildings in Chennai suffered extreme damages again due to water quality only. So, your
Oh,
views on the water quality have been taken granted from the government side?
see, water quality, yes, it is a very important factor because normally for new construction, water quality plays an important role because if it has got already chloride content, sulfate content, yes, it is going to uh, corrode the reinforcement in the near future actually. Because actually corrosion starts when the chloride content reaches its threshold level. Okay, so if water quality has already got the chloride content, so that means chloride has already reached to the surface reinforcement. Now, because of the hairline cracks or uh, surface cracking, that surface chloride concentration also permeate up to the reinforcement. So once this chloride content reaches the threshold value, then only then this corrosion starts actually. So yes, water quality has to be maintained in the construction, I would say, because if internally you do not have chloride, then we have seen that surface chloride, it takes about maybe 25 to 30 years to penetrate to the reinforcement depending on the permeability available in the concrete. And if it is a good quality concrete, then permeability will be very low actually, and diffusion will be very difficult, I can say actually.
Okay,
Thank you
sir.
for your
Thank you.
insight, sir.
Yes.
Yes, Nakul ji, boliye.
Uh, I think so. All the questions are answered to all of you, and now we thank you for this informative session today, sir. And I think so. Anish might have something to say. Anish, it's up to you.
Yes, sir.
Sir,
Dr. Sharma this side. I'm taking the lead now.
Okay. Okay.
So,
Okay.
thank you, Dr. Kapilesh Bhargava, sir, for commencing our discussion on structural longevity with such a rigorous session on aging management of existing civil structures. Your insights, backed by 34 years of experience at the Bhabha Atomic Research Center, provide an unmatched benchmark for structural reliability and ensuring that infrastructure commitments are truly sustainable.
Thank you. Thank you very much for your kind words. Actually. Hello.
Thank you, sir. Thank you, sir.
Yeah, yeah.
So
So,
now, sir, we have another session from 7:30 to 9.
okay. So,
So,
shall I
sir,
leave with your kind permission?
yeah, sir. Yes, sir. Thank you, sir.
Thank you very much.
Very
Thank you very much for giving me an opportunity to speak about my experience. Thank you very much.
Thank you, sir.
Thank you.
So now we are heading towards our final session of day 3. Dr. Bhargav demonstrated how science ensures longevity. Our next speaker will show us how digital technology enables that performance from the outset. Our session 6 from 7:30 p.m. to 9:30 p.m. is on the pivotal topic application of building information modeling for sustainability related goals. We'll be starting in 5 minutes.
I think so. Dr. Sagar Balsane sir is in the group.
Okay, sir.
Sagar sir, are we audible? Are we connected?
Yeah, I have joined. Thank you.
Oh, thank you, sir.
Am I audible?
Yes, sir, you are audible.
I'm
Uh,
pleased to introduce Dr. Sagar Madhav Malsane, a leading voice in digital construction. Dr. Malsane is a senior associate professor and interim dean of the School of Real Estate and Facilities Management at the NICMAR University, Pune. His 18 years of experience and PhD in automated code compliance using BIM from the UK make him the ideal guide for this session. As the conceptualizer of the Center of Digital Construction at NICMAR, he will show us how BIM drives resource optimization and energy efficiency. So, sir, the stage is all yours.
Okay, thank you. Let me share my screen. Good evening to all. Yeah. Can you please confirm my PowerPoint presentation is fully
Yes,
visible?
sir, it is visible and your voice is audible.
Yeah, okay. So good evening to all. So the topic which has been given to me is application of BIM for sustainability related goals. So typically, I mean, when I saw last session, it was fairly technical. Uh, 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 but I feel this topic is a good blend of technology related aspect as well as management related aspects. So typically, how we can achieve sustainability related goals at industry level as well as at project level through this innovative concept of BIM. That will be the focus of today's presentation. I'll try to cover uh, uh, different topics, but wherever you feel like asking me something, please raise your hand and ask freely. So that it will make the whole experience of teaching learning more fruitful. And also, whenever you can also use chat section if you want to type something. Okay. So the broadly the presentation focuses on how BIM will be applicable at project level or how we can achieve certain project uh, delivery related expectations through BIM. But one of the expectation is sustainability. So how BIM contributes towards sustainability, that is the focus of the session, or that will be the focus of the session. So some of you might be quite a bit well acquainted with sustainability more than me. Here I'll bring my expertise from BIM perspective, and I will try to contribute from that perspective. Okay, so typically, uh, we all work in construction, or some people also try to refer it as eco industry, architecture, engineering, construction, and operation industry. So, if I have to ask you, what are the various objectives for which the construction industry really stand for? What is really expected from construction industry? Something very easy. I thought that will be a good icebreaker just to start with. What is expected from the construction industry, or what should be the goal of, or what should be the objectives of construction industry, if one or more than one? Anyone?
Quality construction with minimum
Quality, time, and cost.
economical construction.
Okay, quality, time, and cost, economical construction. Anything else? Okay. So yeah, so these are the expectations from us as an industry, that this is how we should do our project, or this is how we should complete our project. But typically, if you see, as a construction industry, we get told that such projects should be delivered. We don't get an opportunity too often to sort of conceptualize the projects. Projects are getting conceptualized at government level, or by policymakers. But here our focus is, or what we really known for is, how do we complete our projects? How do we deliver our projects? Our success is measured on the basis of how we complete our projects. Do you agree? So in very simplistic terms, whether, of course, time, cost, quality, safety, all those parameters are there, but typically we expect that there are certain expectations from the construction industry that we should deliver project in a certain manner. And broadly, if we have to put that into simple words, it is, we are expected to deliver projects efficiently. Is that correct? Everybody agrees to that one? Of course, then there are added other expectations, such as projects should provide safe and functional structures. They should ensure safety, compliance. But also, one of the important aspect of projects is that they should fulfill the sustainability related parameters, or they should promote sustainability, or they should be in alignment with the industry's sustainability goal, or nation's sustainability goal, etc., etc. Correct? So what I'm really trying to establish here is that construction industry is not only essentially about, it's no more only about delivering the project. The expectations are quite a bit, or the expectations are much larger. For example, construction industry is no more about only completing the project. People expect, stakeholders expect the project should be of high quality, fulfill quality parameters. It should have a high safety standard. It should be completed on time. It should be done within the budget, etc., etc. So at the same time, in similar vein, it is also expected that construction project should also fulfill the sustainability related goals, or they should promote sustainability. Correct? So from that perspective, basically, we are going to go ahead. So you can see that. So just I thought it will be a good, great idea to have a look at how we are doing well, or are we really delivering projects efficiently. So just a small statistics I thought I will put in front of you. You can see that 440 infrastructure projects show cost overruns of 4.3 lakh crore. And this data is by Ministry of Statistics and Program Implementation. So these are all, so this particular body, of course, it's a data from 2020, but I'm sure that not much has been changed. So this particular ministry, or this particular body, has monitored projects which are all having 150 crore and above budgeted cost, and they monitor in total 1671 projects. So you can see that more than 30 projects, more than 30% projects are showing cost overrun, and more than 30%. So cumulatively, 63% projects are showing time and cost overrun. So that's not really a great stat. That does not augur very well as an industry. It does not give a great reputation to the outside world, that how good we are as an industry. So this has been a debate. Of course, there are a lot of reasons behind that. We are not going we are not going into those reasons. That is not the focus. And some of those reasons for not having such great result may be justifiable. But typically in general, global construction industry is also not having a great track record when it comes to delivering project efficiently. So globally also construction industry is lagging behind, and then similarly Indian construction industry is also lagging behind when we compare the industry with other parallel industries such as manufacturing or automobile, etc., etc. Of course, there are always justifications. We can say that uh, uh, automobile industry, etc., they don't necessarily face those kind of challenges which our industry encounter, or or our every project site is dynamic. Every project site brings a new challenge. The learnings which we got from our last project, not necessarily I can use all those learnings immediately in my next project, because my next project throws different challenges. All that is fairly acceptable, but still more than 60% projects having time escalation and cost overrun does not augur a great picture. So from that perspective, it has been it has been a common theme, or it has been a discussion which is going on for years, that we need to think the way we are delivering projects. We need to question our method of how we are approaching projects when it comes to delivering them efficiently. Correct. So industry leaders, uh, people who have been in the leadership positions, intellectuals, academicians, on different forums, this sort of discussions have been going on. Okay, so essentially, what I'm trying to say is that people have been looking for different innovative solutions, and building information modeling is sort of one of that technology based solution which has the potential to sort of increase the chances of delivering the project successfully or efficiently. So so then the question arises that when we are not able to deliver project successfully, what are the challenges we are facing, or what kind of struggles we go through, that leads to not being able to deliver project successfully. So of course, some of these challenges, some of these struggles are pretty common. A lot of you are quite aware of it. For example, in general, the construction industry work in a very fragmented manner, in a very silo kind of culture. That means having a very departmental approach, that this is my job. Let's say structural engineering is my job, so I'm bothered, or I'm fully focused on my structural designing. If I have done my job, or if I have done my structural engineering work, I feel that I have done my job fairly well. But then I also need to have the understanding or the realization that my work also affects a lot of other works, or my work has dependency of a lot of other work. So this kind of collaborative approach or mindset is something missing in our current approach of project delivery. Or we are struggling with something as simple as mismatch of drawings. We're just not able to produce accurate drawings which can be utilized on site, and then can be used for execution. Or or a lot of mistakes or errors we encounter in our daily work life. Like projects are facing with a lot of mistakes, a lot of errors, a lot of RFI means request for information. So why lot of request for information? That means information is missing. The information which everybody is looking for is not available, so everybody is asking information from each other. So that leads to friction, because people are not happy that somebody else, like a contractor, is raising a lot of RFIs to a consultant. So the consultant doesn't feel that I have done my job, I have already given enough information, I have delivered my output, my design through drawings, through other submissions. So why RFI is being raised? So that leads to confrontation, that leads to friction, and that hampers the project environment. But on the other hand, if we have to deliver a project efficiently, it's a team goal. So it's really important that people should work in a very amiable manner in a project environment. So that kind of environment is only created when people in the same stakeholders like client, consultants, contractors, vendors, different specialists, they exchange information in a very transparent and in a very efficient manner. When they all feel that they are helping each other, when they all feel that their individual job is getting benefited, or they are getting benefited because of others' work, when that kind of atmosphere is there, then in general the project environment becomes very amiable. And then as I said before, when we are talking about delivering a project efficiently, it's a team goal. Until and unless all people, if they work in a fully synchronized manner, we will never get that ultimate result of delivering project efficiently. So that was in a generic sense that as I said, in general, the construction industry has this kind of challenges or struggles. For example, a lot of data duplication. People, different consultants, different engineers, they keep on duplicating the data. They keep on reproducing data. So that impacts productivity. That leads to a lot of wastage of man hours. So those sort of challenges and struggles the industry is facing with. At the same time, from sustainability point of view, waste and carbon emission is something which is very important. So construction industry has also need to take the responsibility towards reducing waste. So they need to find ways that how can we reduce waste, how can we have less carbon emissions through our the process of construction. Construction industry is known for largest consumer of energy and raw material. So we need to come up with ways how can we ensure that we use appropriate materials, or if optimization of materials, etc., etc. And also our design should be such that we should be able to optimize energy use, reduce waste, and improve operational efficiency. So that is also a challenge that we have to live up to as a construction industry. And from that perspective, people have been saying that BIM is something which can provide a solution, or through BIM we can sort of achieve a lot of those objectives, or BIM has that sort of mechanism. BIM provides that mechanism. If we adopt that fully, the chances are very high that we should be able to deliver project efficiently. Not only that, we should be able to even fulfill our sustainability related goals through BIM mechanism. Okay, so far clear? Any doubt? Anybody would like to ask anything? Okay, so shall I go ahead? Okay.
Yes, sir. Yes.
Okay, so typically when people say that why we need BIM, you can look at that from two perspective. One is industry perspective, that as an industry, why we need to look at BIM, or why we need BIM, why should we adopt BIM. And second is project perspective, that why we should have BIM at project level. So of course, so as I said, BIM is a technology based solution. So when it comes to technology adoption, architecture, engineering, construction, AEC industry, or construction industry in general, it is lagging behind in comparison to other industries. So that is one of the motivation, that we should be at par with other industry in terms of technology adoption. So that is an industry perspective. Because we have seen that with traditional delivery methods, we are still not able to finish projects efficiently. Our track record doesn't sound great. So that means we need to change, or people need to change the approach towards projects. So that is one more reason that why we should have BIM. In general now, because of the visualization aspect, uh, construction industry needs to move from 2D CAD practices. We have used CAD enough. We have already done one transition, which was use of manual drafting and shifting from manual drafting to CAD based practices, computer aided drawings. And now time has come that we should move on from 2D based practices, two-dimensional based practices to 3D BIM. So coordination and completion overall, productivity and efficiency. It's very important that our productivity at various project life cycle stages, that means at design stage, at procurement stage, at execution stage, our productivity cannot be stagnant. It has to improve all the time. So from that perspective also, uh, as an industry is looking at BIM. Industry expect people to have a lot of collaboration on at project level. So that means improved collaboration is one more reason. And then if you have to particularly focus from sustainability point of view, you can see that I have highlighted that waste minimization is very important. So how BIM can really help in terms of waste minimization. That is something industry is very keen on, so that as an industry also it improves their track record when it comes to sustainability, as well as their performance. So waste minimization, producing smart and resilient infrastructure. So again, for that, BIM is very, very important. And then some of the sustainability goals, SDGs, those SDGs which are having direct impact or connection with BIM. SDG 9, 11, 12, 13. I'm going to show you a small table that shows that how BIM and these SDGs are connected. So even construction industries also, if it wants to sort of show that their great track record against SDG, BIM can be highly helpful. When it comes to project perspective, of course, we need BIM at project level first and foremost for better visualization. You can just visualize the project in a far better manner the moment you have BIM. We want well coordinated design documents. So from that perspective, we require BIM. A lot of change orders and rework. We want to reduce that. Currently, in construction industry, the owners are not really satisfied. Our customer satisfaction rate is also pretty low. So how can we improve on that? So again, BIM is there. Tight profit margin. So already stakeholders, consultants, contractors, they are working on tight profit margins. So if you don't improve on productivity, if there is a lot of wastage of material, if there is a lot of wastage of man hours, that puts pressure on organizations or stakeholders who are involved. We want to improve our decision making, correct? So typically, whoever works on a project, people don't go with an assumption that people in the sense stakeholders or architects or engineers or consultants, they don't go with the mindset that I'm going to end up making a lot of mistakes. But still, people are making a lot of mistakes at project level. They're still showing a lot of poor decision making simply because they are dealing with a very poor quality data. So how can we improve our quality? How can we improve the quality in our information? So BIM particularly focuses a lot on that aspect. Difficulty in responsibility fixation, that is another aspect. So from that perspective also, we need BIM. And then, as I said, BIM has a great potential. BIM's 6D energy and carbon analysis can be a great asset or can be a great dimension for BIM's project success. So 6D BIM we need at BIM level, and BIM can at project level, sorry. And BIM can be highly useful for even when it comes to compliance with various green building related organization, IGBC, GRIA lead, or even for environmental compliance, because through BIM you can produce information which can be highly useful, which can really help in achieving all these compliances. So from that perspective also, we need BIM at project level. Okay. So this was about a sort of a background context setting, that that how the construction industry is doing well, what is the status of construction industry, what are the challenges, struggles of construction industry, and then why do we need BIM at industry level and at project level. But then really the important bit is what exactly BIM is all about. So typically, this particular acronym BIM stands for Building Information Model. So you can look at that acronym in two different ways. If you see in my screen, on my left side, you can see that BIM as an acronym. That means it represents a 3D model, but it represents a 3D model with lot of information. So if you really break down this term, building information model, the building stands for the action of building something. So it's not really a verb. Many times a lot of people come and say that BIM means it is a concept which is associated with building, so it has nothing to do with infrastructure, it has nothing to do with a road project which I'm working on, it has nothing to do with a bridge or a metro project. But but essentially BIM, this acronym stands for you're building a 3D model with lot of engineering information. So you need to embed information, you need to author the 3D model with lot of various parameters. I refer to that information as engineering information, or information which is having an engineering flavor. For example, if I'm using doors in my project, whether those doors are having fire resistant capacities or not, and whether it has been mentioned there or not, or are there enough escape routes provided in my design or in my building, etc., etc. So whether the column the structural column shows the reinforcement details or not, or whether the column has the concrete quantity mentioned as part of information or not. So that kind of information should be there. So when you have that kind of information, then you can refer to as building information model. So if I have to just show you, look at here, for example, this is a typical example of building information model, which is graphical as well as information model. When I say graphical and information model, that means it shows the 3D aspect, that's why it's graphical, but it has information model because I can extract a lot of information from this model. I can extract material quantity from this model. I can extract number of doors, number of windows. I can filter out data floor wise. I can filter out data source wise or discipline wise. Like I can filter the architectural data, I can filter the structural elements, I can filter the MEP system related information, etc., etc. So that's why when we look at BIM as a standalone, we are only referring to a 3D capability of BIM. Okay, but if you look at BIM holistically, then you will have to look at BIM as a approach or as a method or as a mechanism, and that particularly represents that how people come together for a particular project and how they work, how they exchange information, and as a team how they deliver a project in a highly efficient manner. Okay, that is the basic intention behind BIM as a collaborative process. So if you see ISO 19650, which is the international standard for BIM, what does it say? It says that BIM is the use of shared digital representation of a built asset to facilitate design, construction, and operation processes and to form a reliable basis for decisions. Okay, so if you have to really break down this definition, it talks about creation of a digital representation. Okay. And then it's not only about creation of a 3D digital representation, but also it has to be shared among all the people. And this digital representation has to be about a built asset. And why we do that? To facilitate design, construction, operation processes. So you can see that. So it encompasses the whole life cycle of the project. Okay, so what are the three? So basically, it is about creating a database. It is about creating that information repository, data repository, and that forms a basis for a lot of decision making. So all stakeholders, they can access this information. They can use this information and use that information to make decisions. And then similarly, and then it applies to all kinds of consultant. It applies to all kinds of engineers. It applies to all kinds of project participants. So sustainability experts can also use that information to make decisions which are related to sustainability, like energy consumption or energy modeling, or understanding carbon embodiment, etc., etc. Correct. Three aspects, if I have to highlight: shared digital representation. That means it emphasizes collaboration and information exchange among all project participants. Correct. So it is really crucial for BIM uh, uh, to have collaboration and information exchange. I mean, that is the heart of BIM process. That how people will come together, how people can come together through a common platform, and then how that common platform allows people to collaborate, exchange information, and then uh, brings efficiency and increase productivity. Okay, throughout the life cycle, that means BIM supports every stage. So it's not only like many times there is an impression that BIM is all about focusing on only, or it focuses predominantly on the design stages, etc., etc. But it is not. It sort of, as I said before, it encompasses the complete life cycle of the project. That means it starts from planning, design, construction, operation, and even decommissioning. And then because we are talking about having BIM as a having BIM based data repository, that means the project information which is on a common platform, which is accessible to all project participants, a digital representation of the built asset. That means it becomes a basis for decision. That BIM ensures that data is accurate, up to date, and usable for decision making. So all project participants can access that information. So they are they are responsible for updating the information, as well as they are responsible for as well as they are responsible for sharing information, and they can utilize that information for further enhancing their input or output. Okay, so that is the core concept of BIM. So in nutshell, if I have to sort of summarize this, BIM, when you refer BIM, you can refer to BIM as a simple standalone 3D model. That means then you are not really focusing on process part. You are just fascinated. You are just sort of really happy with the 3D capability of BIM. You are really impressed by the visualization aspect of it. You really feel that yes, that is a great tool to have, the 3D model with me, which I can use it for various purposes. But if you really want to be very formal about BIM utilization, if you really want to sort of achieve that ultimate goal of delivering project super efficiently, then you should look at BIM as a method. And as part of that method, you have to sort of follow the complete mechanism that how I can use BIM on a project. So then it involves three stages: model authoring, which is object-based modeling, then model-based collaboration, where people will share model, and then network-based integration, means through a common platform, people will come together, participants will come together and work on a common project. Okay. There are various other explanations or definitions available randomly. BIM is a term coined to deal successfully with the problem of fragmentation and error in the process of building project creation till its implementation. So it just talks about one of the capabilities of BIM, which is successfully dealing with fragmentation and error. It removes fragmentation by bringing all people together through a common data environment, by allowing people to use a common platform. To make it very easy, I sort of provide an example to my students that it is very similar to buffet food system, where in a buffet food system, you allow people to eat from a common table and there is complete transparency. All the food items are fully visible for each other. People can really see who is eating what, how much, who's eating how much, etc., etc. So that kind of BIM talks about that kind of transparency. BIM talks about that kind of value proposition where people are having access to the latest information. Then another definition, it refers to a collaborative method of working that is based on the generation and exchange of data and information between the various project parties. Correct? So as I said, the method part really focuses on the information generation, information exchange, and how effectively that information can be used to enhance the project delivery. Okay. And it is based and it is applicable to the full life cycle of the project from conception to completion. Okay, so just to give some sort of glimpses, look at here. This will be an example of a typical standalone building information model, and from the same building information model, you can generate so many different outputs: a sectional view, an internal 3D view, a sectional 2D view, a cut section, etc., etc. Okay, so the first part of BIM is it focuses a lot on how we produce drawings, or it focuses a lot on drawing production part, because that really is a very significant step towards achieving project success. Correct? So through BIM, what has happened that it has completely revolutionized the drawing production process. Typically, we produce drawings in a 2D format, and that process is very time-taking, laborish, etc., etc. So through BIM, that whole process has been sort of transited to a new approach, which is called as object-based modeling. Correct? So instead of now drawing, instead of making 2D lines, instead of making line diagrams, which we typically refer as 2D drawings, here the approach is about using 3D objects, okay, predefined 3D objects to create building information models. Okay, so that's why you can see that here it is mentioned 3D geometry is only part of the BIM. Okay, so just because it has 3D geometry, that does not mean it is BIM, and not all 3D models qualify as BIM. Not everything which looks 3D is BIM. So you will call it as BIM when it has geometry, but it also has all the building components, and it has shared data and knowledge. So it has all the parameters, all the information. It has all the sustainability related information, parameters, etc., etc. Okay. Okay. So far, all good. Any doubt? Anybody would like to ask anything? Okay. So just to take it ahead, so you can see that so the first part was about looking at BIM as a 3D model, and then how it sort of revolutionized the drawing production part. So it also helps architects to create 3D models. It helps structural engineers to create structural models. It helps MEP people, engineers, to create MEP data. And then at the same time, it also helps the energy experts to do the energy modeling. It also BIM also allows sustainability expert to sort of provide to embed sustainability related information into the 3D models. Like for example, if you want to use eco-friendly material in your 3D model, so through BEAM you can do all those kind of permutation combinations. So the first part of BEAM is object-based modeling or model authoring. So as part of model authoring, it is expected that different stakeholders, as per their expertise, they will produce models. So architect is expected to produce architectural model, a structural person, structure engineer is expected to create a structural model, MEP engineers are expected to create MEP models. Similarly, and sustainability expert or an expert in energy analysis uh, or or something similar, they are expected to provide their input into this model. So it might be related to use of sustainability related materials, or use of or customizing designs or changing designs to make it more energy efficient, etc., etc. So all that work will be enhanced because of object based modeling or through object based modeling. Then model based collaboration is all about bringing people together, and then they utilize each other's model for enhancing their input or output. Okay, and that really impacts the productivity in a very positive manner. And then third one is network based integration. So until and unless you don't bring people together through a common platform, through common data environment, your network based integration through network based integration, your real collaboration will never take place. Correct? And that is why BEAM as a collaborative process includes these three major stages. Okay, so if you see the picture here, you can use different software applications, okay, to provide their own individual input. Like you can use Revit to do the architectural modeling, structural modeling. But if you want to do energy analysis, you can use Revit Insight or something similar kind of software. Navisworks for collaboration, Solibri for quality check. So BEAM allows people to work in a very democratic manner, and through BEAM, people can share each other's information or access each other's information. That is the real beauty behind this whole process. So somebody who is an expert uh, in in safety, he or she doesn't have to create a separate drawing or model. They can access an existing model, and then they can provide their input from a safety perspective, and then they can just enhance the design. Same is applicable for sustainability. So sustainability related goals can be targeted at design stage, and then accordingly the designs can be customized or developed further. Okay, so that's the sort of goal or approach behind it. Now, so BEAM also, one of the important concept of associated with BEAM is producing an integrated model. That means all stakeholders, they are expected to sort of create their individual models, but then essentially all these discipline specific model files, they have to be brought together to look at it in a very integrated manner. Okay, so that means you are allowing people to have a free access to information, and by having that access, they are using that information to enhance their individual output or to enhance their individual expertise. Okay, and that really helps in terms of uh, improving productivity or reducing wastage, or many times when people work together, knowing unknowingly they also create hurdles or problems to others or other work. So this kind of, because of this transparency, because of this kind of availability of information, those sort of challenges can be tackled very easily. Okay, and then of course owner can also have an access to all this information. So his visualization also goes to a different level, and then his input also improves, or his decision making also becomes far better, which helps all stakeholders, because his decision making is also very crucial for their work. Okay, so integrated model means bringing all model files of different discipline, including sustainability, and putting them together to have a very holistic view of the complete project at the design stage, before you start your execution. Okay, ठीक है. So these are just different softwares or solutions for different uh, objectives or work profiles. For example, site design, building design, plant design, design review, clash detection, documentation, visualize. So these are different abilities of BEAM, which you can use at various levels as per the requirement. Okay, but essentially it is all about creating a digital representation, 3D digital representation. Typically, you can see that how the workflow goes: pre-construction, construction, and operation stage. So, so once the requirements are fully established, conceptual designs can be worked out. Using those same conceptual designs, detailed designs can be developed, and you can see that using those detailed design, various types of analysis can be carried out. So it might be related to structural analysis, it might be about energy analysis, energy consumption, material utilization, different material utilization in the project, etc., etc. Correct. So that is so this is the workflow where different project participants are using an existing data or information to produce an enhanced output. That means now they are no more reworking, they are no more duplicating data. There is no issue of inaccuracy, because a single set of data is being used. And that's why in BEAM you will often come across this term called as single source of truth. So the whole idea is all project related information has to be deposited at a common platform, and from there all information, every piece of information can be accessed. So the information has only one single source of truth, only one single source, and that information is always updated, or is expected to be updated, so that people, different project participant, they have access to the same information all the time. Okay, so it sort of takes out a lot of errors and mistakes which happen at industry level. Typical workflow, if you see, you have to initialize the project through BEAM, then modeling phase, inter-office works, and field works. Field works refers to execution. So if you see that, first the client has to sort of take that mandate, take that call that yes, we need to have BEAM on our project. Then modeling phase, and then in modeling phase it is important that in 3D models rich data about materials, geometry, and system has to be incorporated, and that can really help in terms of achieving sustainability related goals. Okay, because now you have all the information about what kind of materials you are being using, what are the geometrical what is the geometry, what are the dimension, what is the data, and then what are the different systems, MEP related systems. So that kind of modeling, or that kind of model authoring has to be there, along with quality check and review, uploading of models, etc., etc. Inter-office works basically represents how people work in a collaborative manner. So different people from different backgrounds and different departments, how they use each other's model to sort of do further processing or further enhancement of output. Like for example, creating merge model, clash detection, 4D, different dimensions of BEAM, 3D, 4D, 5D, and then 6D particularly focuses on sustainability and energy analysis. Correct. So in inter-office work, it is expected that the models which have been created at the modeling phase, those modeling data, or those models will be used. That model will be used for energy consumption, understanding natural lighting and ventilation, thermal comfort, utilization of water and material efficiency. So all those kind of simulation, those kind of analysis need to be done before execution, so that this really helps towards achieving your sustainability related goal. Okay. And then of course, once all this work is fully done, all this work is fully weighted by beam coordinators or by beam engineers or by beam managers, all this data is being made accessible to people who work on site, and it is called as field work. So those people can access that data and use that data for execution. Okay. Uh, some of the core values which are associated with beam, uh, I'll not go too much detail in that. Uh, Productivity, early risk mitigation, reuse of project information, early risk visualization aid, concurrent working, how people can work from different places in a with a dynamic linking, etc., etc. Okay, and that really enhances the productivity. But I really want to show you how some of the beam core values are having direct connection with sustainability. So you can see that when we say that collaboration, it promotes integrated design and decision making that balances social, environmental, and economic goals. Correct. So because of collaboration, it also helps stakeholders to achieve sustainability related goal. And collaboration happens through shared working environment using a common data environment. Just some time back we discussed about that. Or if you have to take an example of transparency and information sharing, correct? So open and structured exchange of data through standardized format like IFC, ISO 1960. And how it helps? It has tracking of sustainability metrics such as energy use, material sourcing, carbon footprint, etc., etc. Correct? So in a way, directly or indirectly, beam, even if you don't have a sustainability related goal, it sort of supports the sustainability, because beam itself is a concept which is so inclusive, which promotes inclusivity, which talks about how we can reduce waste, how we should not duplicate data. So at its core principle also, uh, the concepts, beam's concepts, core principles also are having strong correlation with sustainability. It talks about producing quality data, and when you start producing quality data, of course, by utilizing that quality data, everyone's information decision making becomes better. That means indirectly it promotes sustainability, because then in the context of sustainability also your decision making will get better. So that is the idea behind that. One of the core value of beam is accountability and traceability, and it helps in terms of governance, compliance with sustainability standards like GRIHA, IGBC, etc., etc. And because of the availability of data through BIM, getting all these compliances become far easy, and the auditability also becomes very efficient. Okay, so okay, if I have to talk about integration of technology and performance, it combines BIM with simulation tools such as energy simulation, day lighting, water consumption, etc., etc. Correct. So BIM, different core values of BIM have a very strong connection with sustainability aspects. Uh, of course, and then typically there are a lot of benefits which are associated with BIM: better collaboration and communication, coordination and clash detection, productivity, increased productivity, better prefabrication, your sites become more safe. In general, the build quality becomes better, etc., etc. Okay. What are the different roles and responsibility in a BIM environment? So for example, you always have those typical roles and responsibilities such as uh, 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 BIM modelers or BIM model authoring, BIM coordinator, BIM architect, BIM manager, etc., etc. But you you will also see a lot of very domain specific job roles such as BIM sustainability coordinator, in model authoring, you will always need a lot of people for energy modeling, BIM facility manager for handling asset information model, BIM sustainability specialist, etc., etc. Correct? So BIM has a very strong correlation with sustainability. If you have to look at different dimensions of BIM, so there are so BIM starts with 3D. So that is the third dimension of BIM, which is for visualization and clash detection. Then the fourth dimension is visual scheduling, which is about how you integrate your construction schedule with your model data, 3D model. Then your estimation through 3D BIM, you can quantify, you can extract all the material quantities, and then you can convert all that into a BOQ. Correct? So you can find out the cost of your project. You can create a budget from that information. And then 6D is about sustainability assessment. Correct? So your energy analysis, your sustainability goals, that part gets covered in the 6 dimensions. So 3D, 4D, 5D, and 6D is very important aspect of BIM. I'm skipping other dimensions for time being. Uh, so so 6D sustainability and energy performance, what really it stands for? It refers to integration of sustainability related data such as energy performance, carbon footprint, and life cycle information into 3D model. So at modeling stage, it is extremely important to incorporate this data, okay, by having a sustainability expert in your project. So an architect can also take and help from the person and who can this kind of expert, and then that person can help in terms of energy performance, reducing carbon footprint, etc., etc. The 3D model is enriched with 6D data such as material properties, energy parameters, and sustainability metrics. So this is very important that that what kind of material you are using. So through 3D models, it becomes far more easier to understand the properties of those material, to understand the visual appeal of that material, and then various parameters which are fully focusing on sustainability. So those parameters uh, can be provided with information, okay? And because you embed that information, as I said, this same data becomes very useful for carrying out simulation. This same information becomes very useful for getting approvals, compliances, and it also helps in terms of auditability, okay? We can have specialized tools such as Revit Inside, IES, VE, Safera, One-Click LC, etc. for energy modeling or energy simulation, etc., etc. Okay. Uh, of course, as every concept or as every innovation comes with resistance, comes with challenges, BIM also encounters a lot of challenges. The cost of software and hardware part is one of the challenge. A steep learning curve, cost for training of people, transiting from an established practice of doing construction projects for 10-15 years and now suddenly transiting to a completely new workflow. There is a lot of cultural resistance to it. There is a lot of mindset related resistance to it. So and of course comfort zone, people are happy the way they are currently working, or it is very difficult for everyone to come out of the comfort zone. So those kind of challenges BIM is encountering, okay? And if we have to talk about different maturity levels, correct? So these maturity levels have been defined in with the perspective that when you are utilizing BIM at a project, to what extent up to what extent you are using BIM. So the more significantly or the more holistically you are utilizing BIM, that means you are having high maturity. Okay, so the maturity concept, BIM maturity concept, is applicable to project level, as well as you may correlate the same concept to organization level, that as an organization what kind of maturity you have or what kind of capability you have, or at a project level what kind of BIM maturity you are trying to achieve to when you are implementing BIM. Okay, so for example, if you are not having any kind of collaboration, that means it is a sort of a level 0 BIM maturity, or you're still not using any 3D models for visualization, etc., etc. You're still going ahead with your 2D CAD practices, then that's level 0. Level 1 is partial collaboration. That means you have started using 3D, but you are also relying on 2D CAD. Full level 2 maturity means full collaboration. That means now project teams are using 3D for modeling, as well as they have started sharing models for collaboration. Teams are using IFC as an interoperability format. And in terms of BIM dimensions, now they have developed the capability to use 3D clash detection, 4D and 5D, which is at level 2. But if the if the project is having a level 3 maturity, that means they are having full integration. That means they are using a common data environment for exchange of information. They are exchanging information through cloud-based environment. uh, so not only 5D, but now here in level 3, it is expected that now they are going up to 6D. That means sustainability and energy analysis. Okay, so they are incorporating sustainability at model authoring stage. They are incorporating sustainability at at collaboration stage, and people are working in a collaborative manner, which helps in general achieve sustainability. Okay, so that's why, so if you want to complete, if somebody wants to sort of achieve sustainability related goal at BIM project, then they have to reach up to level 3 maturity. I'll quickly sort of show you the correlation between various BIM dimensions and maturity levels. So you can see that the more mature you are, that means you are targeting higher levels of BIM dimension, or the more higher levels of maturity levels you have higher BIM dimensions capability. So 1D, 2D, 3D. So you can see that at level 3, it starts with 6D, building performance or sustainability related aspects. Okay. And then same goes for even level of detail concept or level of development concept. The more higher you go, that means you are incorporating information into your 3D models, which is about sustainability. Okay. So just a quick glimpse of that. So for example, look at here, different level of details have been conceptualized in BIM. LOD 100, level of detail 100, level of now it is also being referred as level of development. So at what level your project has been developed? So 100, 200, 300, 350, 400, 500. Those kind of stages have been developed. Conceptual, 100 is conceptual, 200 is schematic, 300 is detailed design, 350 is coordination, and 400 is construction. So you can see that at detail, so if you want, if you expect that you are having LOD 100 conceptual model, what sustainability related focus you can bring is site orientation, solar analysis, initial energy goals, etc. So those sort of those sort of goals you should have at conceptual level. But as you move to schematic design, that means it is expected that now you are doing energy modeling, you are having more thorough daylight analysis, you are you are taking into consideration about consumption of water, etc., etc. And then as your model is getting more mature, as you are starting putting more details, so LOD 300 detailed design, uh, other concepts will come in picture, such as thermal performance, embodied carbon, HVAC optimization, lighting analysis, electricity related consumption. So so this is how. So the more detailed your project gets developed, level of detail, the higher the level of development, the better the more mature your sustainability goals will be. So there is a direct relation, uh, or the level of details and sustainability is directly proportional to each other. So at at LOD 400 at construction level, the focus will be more on how we can procure how we can have procurement practices or sustainable procurement practices, how we can have material optimization. The focus is on how to reduce on-site waste, how to have logistic efficiency by using BIM related data, etc., etc. Correct. So this way it is highly useful. The concepts such as BIM maturity, BIM dimensions, and level of development. Those three are strongly correlated with each other, and they all three shows the similar pattern. The higher you go, the better result you can get it. Okay. And then next concept is common data environment or data repository, basically, which allows people to work through a common environment, and that really augurs very well for exchange of information and for better decision making. Just a quick summary of how how you can look at two different practices. So look at here, conventional practice and beam based practice. So in conventional practice, you can see that different project participants, they are generating information which is in a compartmentalized manner, and it is in silos, and that is applicable to even information related to sustainability or information related to energy modeling. And on the other hand, you can see that all the information is put together, integrated into a common single database, which we refer to as a 3D digital model or a digital representation. So which acts as a single source of truth, and all the information will be accessed through this common single source. So client, architects, MEP engineers, contractor, facility managers, to manage the facilities very effectively, to reduce daily operation energy consumption, all that, this kind of information will be utilized. So so this picture very clearly indicates the contrast between the two approaches. Okay, and that is really the key for successfully utilizing BIM. Okay, then then another important concept is asset information model and digital twin. That once you develop the model fully, the building information model, so the fully developed building information model contains all the information about that asset in terms of all the properties, all the finishes, the warranty, guarantees. So you can basically use that asset information model to maintain that structure, to maintain that asset, to carry out maintenance work, etc., etc. But once your building information model is completed and once it is utilized on site, then it becomes a static model. So and then and your built form becomes dynamic, because your build form is now undergoing a lot of changes. There's a lot of energy consumption is happening. There is footfall of people, car entering into your building. So all that data can be captured and that can be incorporated into the digital replica of that project, and that we refer to as digital twin. Okay, so as asset information model and digital twin, they appear similar, but there is a unique distinctness about them. And then you can use this digital twin, which is dynamic. You can make a lot of informed decisions on the basis of data which is present in your digital twin, and that way you can achieve more efficiency, which is again one of the goals of sustainability. Okay, and that's why digital twin has also been referred as the living version of the project. Okay, while the asset information model is the static version of the project. Okay, and then you can also utilize the concept of BIM execution plan for procuring all the services of BIM, including sustainability. Okay, so BIM execution plan is a very key document which basically focuses on how a client can procure BIM related services in a very formal manner. So BIM execution plan provides that document that defines how a building information project will be executed, managed, and delivered throughout its life cycle, including sustainability. Okay, so I'll not go too much into that one. It's just that there are two types: pre-contract BEP and post-contract BEP. So very important. And then typically, if you have to really focus on sustainability related goals, then as we discussed before, energy modeling is something which comes at the forefront of BIM and sustainability. Okay, so at the modeling stage, at the BIM authoring stage, energy modeling can take place. Various tools are available. Of course, BIM does not advocate for any particular modeling tool or any particular uh, simulation tool. It allows participants to use different technological solutions, and through IFC, people can exchange information from one software application to another software application. So first goal related to sustainability is sustainable design and analysis. So that happens at the object-based modeling stage or model authoring stage, where various tools like Revit Insight can be used to analyze energy consumption, daylighting analysis, thermal comfort, or renewable energy potential. Okay, so at design stage, all those kind of simulations or energy analysis processes can be carried out, and that way you can make your designs more sustainable, or you can incorporate sustainability into your designs. Then material optimization. Designers can evaluate material based on embodied carbon recyclability or environmental impact using BIM link databases. Correct. So a lot of understanding about materials can be developed. The awareness about material can be increased at design level. Specialists can be included to help architects to select right material, which can really have a positive impact on sustainability. So that can happen through model-based collaboration. Correct. And then architect can also utilize passive design strategies through visualization, or software such as Revit allows different option in terms of building orientation, shading, and natural ventilation. So such kind of simulations can be carried out. Such kind of software solutions are available, which provides different solutions that which is the best building orientation scenario, or how can we have a natural ventilation, what should be the location of windows, etc., etc. So those aspects can be taken into consideration to really make the designs sustainable, or to analyze the designs from sustainability point of view. So here BIM really contributes massively during the early design stages or during the design stages. Then BIM can play a huge role in terms of resource efficiency in construction. Okay, so the 3D aspect of BIM or the 4D aspect of BIM can really help in terms of waste reduction through those dimensions. We can precisely find out the material quantities, reducing over ordering or handling that material on site in a very effective manner. So different dimensions of BIM can really help in terms of waste reduction. In fact, some of the concepts of BIM and Lean can be integrated to really worked out solutions for waste reduction. So if you see holistically, BIM talks about not duplicating the data, not reproducing, it talks about having minimal errors on site, etc., etc. So automatically that reduces waste in a very holistic manner. Correct. Then through beam prefabrication and modular construction can be facilitated. So offsite fabrication really improves quality, reduces waste, and minimizes site disturbance. So that can be done through beam, and and 4D aspect of beam, which is about visual scheduling, that really helps understand the construction sites to visualize the sequence of workflow, to identify bottlenecks, to understand ideal equipment time, and strategize for better resource utilization. So that really helps massively in terms of resource efficiency, and resource efficiency is one of the important aspect of sustainability goal. Then BIM also contributes towards the operational sustainability. We have already spoken about energy management. We have already talked about energy analysis, but facilities management also BIM contributes massively. We can use the information which is produced, which gets produced as part of BIM. That information, which is the complete project digital representation, that information can be utilized for facilities management. Correct? That means you can really reduce your daily operational cost. You can really reduce your energy consumption. You can really make your projects more sustainable during the facilities, during the operational stages of the project as well. So facilities management is also a very important aspect of BIM and sustainability correlation. Then through BIM, different smart systems can be integrated. For example, making use of integrated building management system, so IBMS. So IBMS and BIM data can really can be merged together to really come up with solutions which are highly energy efficient. We can introduce a lot of automation, and that can really reduce the consumption, the waste, and that makes projects more sustainable. And then life cycle assessment, BIM helps in terms of assessment of environmental performance over the entire life cycle from design and decommissioning. So that life cycle assessment is also very important for various compliance point of view. So that helps. So this way BIM helps the operational sustainability of project. Then in a very generic sense, if you see here how BIM really helps in terms of sustainability goals, it streamlines the documentation, correct, through BIM, because as we discussed, it is all about having a common shared data available across the whole project life cycle and accessible to all project participants. So that really helps in terms of documentation, which is required for compliances, which is required for certifications, IGBC, GRIHA, etc., etc. BIM supports compliance with sustainability standards, enhancing transparency and accountability. As I said, because of the common data environment. Because BIM's centralized data environment ensures all stakeholders access consistent sustainability related information. So BIM, of course, when we are talking about, when BIM helps having all the information on a common data environment accessible to all, that also includes sustainability related information. That means project participants are always having access to the most updated information about sustainability, and then of course that means there are better results at execution level, even in the context of sustainability. Designers and engineers can simulate multiple sustainability scenarios. Okay, so that means through various simulations, through various scenarios, designers and engineers can come up with an effective and cost efficient solution. Okay, which can be really crucial from the sustainability point of view. And then organizations can reduce carbon footprint and operational energy use and lower life cycle costs through efficient maintenance and retrofits. Correct? We discussed that about facilities management. So as part of facilities management, there's a lot of emphasis on how to reduce operational energy utilization, how to lower the life cycle cost of the project through efficient maintenance. And all that can happen only when you have and most updated quality accurate information through BIM available. Once that information is available with you, facility managers can make informed decision, right decisions, and then really help achieving those sustainability related goals. Okay, so this was about general how BEAM and typical project level sustainability goals can be correlated, or how they sort of help each other. But BEAM can also directly contribute towards some of the sustainability related goals, SDGs. We refer them as Sustainable Development Goals. So, SDG 7, SDG 9, SDG 11, 12, 13, those are the goals which are having direct correlation with BEAM. Okay, so different governments, industries, they that way they are also very keen on understanding the because countries have mandate to sort of be responsive towards the sustainable development goals. Construction industry is also having the mandate to be responsible towards or accountable towards sustainable SDGs. So that way, BEAM contributing towards those SDGs having a lot of significance. It matters a lot. For example, affordable and SDG is about affordable and clean energy. So through BEAM, we can carry out energy modeling and simulation that optimizes the energy performance. Uh, uh, through BEAM, we can monitor and reduce operational energy consumption. So that means you are contributing towards affordable and clean energy, correct? SDG 9 focuses on industry, innovation, and infrastructure. So of course, BEAM is all about promoting innovation, promoting productivity, enhancing productivity, smart construction, data-driven decision making. So that really gels very well with SDG 9. Same way, sustainable cities and communities, of course, of course, use of GIS uh, along with BEAM really contributes massively towards achieving this goal of sustainable cities and communities. Use of digital twin concept can also contribute towards having sustainable and smart city development, etc., etc. Then SDGs 12 focuses on responsible consumption and production. So we have throughout the session, we have discussed about BEAM focuses on precise use of material, and that happens through precise estimation. Through modeling stages, we can really understand what are the materials which are appropriate for this type, for that particular type of design. It facilitates material procurement, and then in a way it helps reducing waste, correct? So responsible consumption and production predominantly talks about how we can be more accountable in terms of reducing carbon footprint, or having an appropriate plan in terms of material consumption, or material selection, or material usage. So BEAM has the potential to contribute massively towards SDG 12. And then SDG 13, which is about climate action. Again, BEAM helps assess and reduce embodied and operational carbon consumption. It supports climate resilience through various technologies which are part of BEAM. You can carry out various simulation related to flood, simulation related to wind, and that makes buildings more resilient, correct? And that can really help in terms of SDG 13, which is climate action. Okay, so this was about BEAM and its correlation with sustainability goals. If I may just take one additional extra 2 minutes, I just like to show you a case.
Thank you, sir, for that truly forward-thinking session on the application of building information modeling for sustainability-related goals. Your insights backed by your PhD in automated code compliance using BIM and your leadership at the NICMAR University, Pune have cemented BIM as the essential digital tool for achieving resource efficiency and informed sustainable decision making.
Hello.
I think it's not
Rakshita, I
complete yet.
think so. It is not complete. Yes, yes, Binay sir is right.
Okay,
Sagar
sir.
sir
You
is
go forward
showing
for that.
one case study.
Yeah, if time permits, I mean, if it is okay, just very
It is okay,
quickly.
Yes,
sir.
sir.
It is okay,
Yes,
sir.
sir.
It
Sure.
is okay.
Yeah. So, for example, just a very simple example. Now, here, this is a case of Abu Dhabi uh, uh, midfield terminal building. It's a airport terminal building, and if you see that the clients which is ADAC, the Abu Dhabi Airport Authority, the client was having a mandate that they want to have sustainability on its project, and and their target was UAE's 2 pearl rating for sustainable design. That means towards this goal, the terminal limits the use of potable water by incorporating dry climate landscaping and use of low energy lighting supplemented by daylight filter through transparent walls, etc. So such kind of various initiatives they were expected to do it. You can see that the picture shows the complete 3D model of the terminal building. It is called as midfield terminal building because it is located between two between two runways, and it's very functional design, X-shaped functional design. So if you see here, the design intent and sustainability goals. So what kind of goals the client set for the project and expected the designers to provide solution. So the MTP's design emphasizes passenger comfort, operational efficiency, and environmental performance. And it has to be done through sustainability objectives such as energy optimization, water conservation, material efficiency, and life cycle sustainability. So, so, so then client was having a mandate that we should use BIM, and through BIM, of course, just like general project should be delivered in a very generic, efficient manner, but at the same time, project should also fulfill the sustainability related goals. So you can see that energy efficiency was achieved through energy modeling. So this was part of BIM phase one, where along with the 3D modeling of architectural structure MEP, energy modeling can also take place. And one of the example of that is optimize HVAC design and daylight use. Correct. So you can use BIM concepts at the design stage to have such kind of energy efficiency. Then water conservation, because the project is in UAE, dry landscape concept, restricted use of potable water. So through BIM simulation related to irrigation and plumbing really help in terms of reducing potable water usage. So BIM based technology can really help carrying out such kind of spatial design as well as scenario based analysis or simulations. Then another goal was material efficiency. Of course, it is very well known that through BIM, you can really precisely quantify the material very effectively, very in a very speedy manner. And then accurate quantity takeoff can also minimize the wastage at procurement level as well as at execution level. And then life cycle sustainability. So as I said before, AIM, which is asset information model. So asset information model based decision making really helps in carrying out the maintenance, data driven maintenance very effectively, and also the consumption of energy. So energy tracking can also happen through that one. Even now people have gone to an extent where they do asset tagging. That means every important asset or every important component in your project is being tagged. So you have complete information about that particular component within your building in your computer, so that you can make a lot of informed decisions. And then carbon reduction, so life cycle assessment guided by low embodied carbon material selection. So such kind of intelligently selection of material at design stage or at procurement stage can really help reducing the carbon. So I just thought that very quickly I'll just show you this example that how people are really achieving their sustainability related goals, uh, through BIM. Okay, so that was the idea behind showing this case. So that's it from my side. I'm really thankful that I got this opportunity to deliver this session. Thank you.
So there's a question in chat box.
Yeah.
Do you see BIM integrating with emerging technologies like AI, IoT, and digital twins in the current scenario?
Yeah, I mean, people have already started using digital twins on various infrastructure projects. Uh, so I mean, digital twin definitely is a reality. Now, now people have started using various AI applications, because through BIM you generate a lot of information, and sometimes it becomes very difficult to sort of interpret that information or handle that information. So through various AI applications, a lot of such data parsing can happen, information filtering can happen, and then various analysis can be carried out. So yeah, I mean, people have already started talking about uh, uh, why to create schedules through AI. We can create schedules, and then how those schedules can be integrated with 3D models, or how with the help of AI we can have various design options for the same building. Similarly, we can have in future we can have various sustainability related design options for the same building. So I mean, it has just started now when it comes to use of AI. Anything else?
Thank you, sir. Thank you for your productive session and valuable insights. So today we focused on structural longevity and digitalization. We learned from Dr. Kapilesh Bhargava that rigorous aging management is crucial for durability and minimizing material waste. And from Dr. Malsane that BIM is the key to efficiently managing those sustainable outcomes. On behalf of Institution Innovation Cell, NICMAR Delhi NCR, I offer sincere vote of thanks to all contributors, to our experts, our deepest gratitude to Dr. Kapilesh Bhargava and Dr. Sagar Madhav Malsane for sharing their specialized expertise. Thank you for sponsoring this vital program. To the team, thank you to the NICMAR leadership and our working committee for their smooth execution. Now, can everybody please open their cameras so that we can have a group picture? A final critical reminder. Please ensure you have a completed attendance forms.
Sagar
For
sir,
both
I
session 5
think
and
so.
6.
We got one more question from Jobil Varghese. He is asking. I'm sorry, Rakshita. I'm means coming in between. The question is, since BIM is collaboration between various stakeholders, how can you quantity individual contributions and responsibilities?
How can you quantify individual contributions and responsibility? I mean, for that, there's a concept called BIM execution plan, and you can also refer to ISO 19650. So ISO 19650 has been particularly designed for establishing individual roles and responsibility and having uniformity in terms of work allocation, or how common standard uniform practices can take place. And BEP basically is a document which sort of talks about individual roles and responsibilities. So through BEP, you can procure all the BIM related services in a very transparent manner, so that it does not lead to any kind of conflict or frictions. Correct? So I hope that was the question.
Okay, sir. Okay, so Rakshita, now we can go for the group photograph. So I will request everyone to please open your cameras. Rakshita, are we done?
Yes, sir. So
Okay,
we are
thank you all.
eagerly anticipating. So you were saying something?
No, please carry on.
Okay. So thank you everyone, and we are eagerly anticipating seeing you all back online tomorrow for day 4, where we will continue our journey through digital and green construction. Good night, and thank you all of you. Thank you.
Thank you, Sagar sir.